Well, we have another question here. The question says that a geometric series has a constant ratio of a half and a sum to infinity of 6, excuse me. So, and then question 3.1, question 3.1 here says, calculate the first term of the series. I'm gonna write the question over here. Question 3 says that the geometric series is a constant difference of a half, so r equal to a half, okay, and the sum to the infinite, s infinite equal to 6. Then 3.1 says calculate the first term of the geometric series, so t1. We know that t1 has the same value, is the same thing as a. That's what we're calculating. Now, what do we know from this? Okay, R is given by Tn over Tn minus 1, okay, the constant ratio, and then sum to the infinite is equal to A over 1 minus R. So in this situation, we can just substitute the values. Sum to the infinite is given to be equal to 6. So I sub in the value of the sum to the infinite, 6 there. And then the constant ratio is also given, it is a half. So we have like A over 1 minus a half. And then 1 minus a half is just a half. So it's like 6 equal to A over a half. Okay. And now we can work out A if we cross multiply, because 6 here has a denominator of 1. So we can just do 6 times a half and then 1 times A. And then this will be 1 times A just A. And then 6 times a half, 6 times a half there. This is equal to 3. So A equal to 3. Therefore, T1 equal to 3. The following question is question 3.2. The question says that calculates the eighth term of the series. Well, now that we know the first term, we can find Tn. Okay, let me first write the question here. 3.2. We're looking for T8. Okay. And because it is a geometric sequence or a geometric series, the geometric sequence will be given by Tn equal to okay, I prefer to write the formula over here. So Tn will be equal to A r to the power of n minus 1. Now T8, we are going to substitute now the values to find T8. It's going to be T8 will be equal to T8 will be A. A is okay. T8, A is 3, and then R is a half. Okay. And then to the power of R minus 1, R is N is 8. Now this will be T8 will be equal to 3 times a half to the power of 7. So that's T8. We can find this. This will be equal to 3, because 2 to the power of 7 is equivalent to 128. So 128. So that's T8. Okay. That's T8. And then the following question is question 3.3. It is said that, excuse me, given that's the sigma notation, that sigma symbol stands for the sum. So the sum of 3, 2 to the power of, excuse me, okay, it says that the sum, it says that given the sum of 3 times 2 to the power of 1 minus k, k starting from 1 to 20 equal to 5,008 okay, I'm gonna say 5,8, not 5,000, 5,8125, and then calculate the value of n. All right, I prefer to move my board this way. And then question 3.3. So we're looking for n here, and then it's given that the sum of 3 2 to the power of 1 minus k, k starting from 1 to 20, from 1 to 20, equal to 5, 8125. So what's the value of n? Okay. Let me see if I write everything correctly here. Yeah, the sum of this 1 to n, not to 20. I was looking down there. It's 1 to n. Okay, so yeah. Here, starting from 1 to n equal to that. Now, what can we do then? Okay, the same sigma notation, this one can be written, okay, the sum for geometric pattern is given by Sn equal to A, open bracket, 1 minus R, I mean R to the power of n, close bracket, all over 1 minus R. And then this sum will be then A is, we found the first term A was equal to 3, open brackets 1 minus R, which is a half. I use this formula because R is in between -1 and 1, okay? If it was more than that, we will use write the other formula R to the power of n minus 1. And then the denominator will be R minus 1. But I use this one because R is in between -1 and 1. Now, so 3 open bracket 1 minus R. So I prefer to use square brackets here because I want to have more to write, more bracket to write. So I'm going to say this is going to be 3 open square brackets and then 1 minus R, which is a half to the power of n, okay, all over 1 minus a half. So this is equal to 5.8125. Okay, and then a half, 1 minus a half is just a half. So this is like 3 open square brackets, 1 minus a half to the power of n, okay, equal to, okay, over half over a half. Oh, I'm just trying to show my fraction line a bit accurate. Over half equal to 5.8125. And then over here, there's a denominator of 1. So we can cross multiply. Let's say whatever here times 1 here. So times this. And then this also times that. And then this will be move my board, split my board like this. And then this would be 3 square brackets open minus a half to the power of n, close square brackets equal to 5.8125 over 2. Okay, when I times by half, it's just over 2. Then I can also divide by this number 3 here. So if I divide by 3, meaning I just times by 3 there at the denominator, it's the same thing. So this will be then 1 minus a half to the power of n equal to this number. We can calculate that. We have like 5.8125 over 2 times 3 and that's equal to 31 over 32, which is 0.96875. So 96875. So if I move the 1 over, that will be negative 𝐴𝐵 to the power of n equal to 0.96875 minus 1. Okay, and then this will be equal to negative 𝐴𝐵 to the power of n. So minus 1, and then we will have negative, it's negative 1 over 32. So negative 1 over 32. And then, okay, we have negative like this. We can cancel these negative signs. And then that makes 𝐴𝐵 to the power of n. Okay, I prefer to write, okay, 𝐴𝐵 to the power of n equal to 1 over 32. Now I prefer to write 𝐴𝐵 as 𝐴𝐵 to the power of n as 2 to the negative n. Okay. Remember the law of exponent that says a to the m equal, okay, a to the negative m, or let's say 1 over a to the m equal to a to the negative m. So that's why I write here 2 to the negative n, and then 1 over 32. 32 can be written in terms of its prime factor. I know this is equal to 2 to the power 5. If you're unsure in the calculator, write 32 in the calculator, and then press the equal button like that, and then press shift, and then press this button here, effect, and then it gives you the prime factor of 32, 2 to the power 5. Now, according the same formula, law of exponents, I can also write 2 to the negative. I can also write 1 over 2 to the power of 5 as 2 to the negative 5. Now, there's another law of exponent that says a to the m equal to a to the n. This implies that m equal n. So we can use this formula to just cross the bases here, and then say, I'm gonna split it a bit like this. That means negative n equal to negative 5, which means that n equal to 5. So the value of n is 5. Okay. Or someone else may also use logs here to work out, but I prefer to use the law of exponents to calculate the value of n. Yeah, the next question says, question 3.4. The question says that if the sum of 3 times 2 to the power of 1 minus k starting from 1 to 20 equal p, write down the sum of 24 times 2 to the power of negative k, k starting from 1 to 20 in terms of p. Okay, I prefer to move my board this way, and then split. This question 3.4. The question says that if the sum of 3 times 2 to the power of 1 minus k starting from 1 to 20, okay, equal to p. So what then the sum of 3, not 3 but 24, the sum of 24 times 2 to the negative k starting from 1 to 20 will be in terms of p. Okay. How can we do that? Now let me think. Oh, right, I think I have an idea. Okay. When I look at this part here is what I need to write in terms of p. Okay. looking at this part, this is what I can do. We can write 24 as 8 times 3, okay, and then it will be 2 to the negative k, and then 1 k starting from 1 to 20. We can do that. Why? Because I know this is almost like that thing, but it's not exactly the same thing. Almost is not exact. But what else can I do? Instead of writing 8 there, I prefer to write it like this. A sum of 4 times 2 times 3, okay? 2 to the power of, actually, 2 to the power of negative k. And then k starting from 1 to 20. Saying that because, you know, we can take 4, the 4 out as a common factor. I mean, out of the sigma notation, okay? So this will be 4 times sum of k, starting because that's a constant, okay? 20 there, and then I left with 3 times 2, 2 times 3, something as 3 times 2, and then times 2 to the power of negative k. And now this can be written as 4, the sum here of 3 times 2 has the power of 1, okay? And then we can compare that the bases here are now constants. You know, when we have same bases, we add exponents. The law of exponents says a to the m times a to the n equal to a to the m plus n. So in this situation, we're going to combine the exponents. I'm just going to write 2 there, and then it's going to be positive 1 minus k. So 2, okay, let me, yeah. So that makes 2 to the positive 1 minus k. So this is exactly what we have over here. Maybe I should change the color. This part here is exactly that. So this simply means we can write 4p. So the sum of 24 2 to the power of negative k, k starting from 1 to 20 is just equal to 4p. Okay. Okay. Or else I prefer to solve this a bit in a different way. Also, or else someone may say this. Okay. We can break this down. Okay, we can write it like, okay, I'm gonna do it over here. We have like that's question 3.4. I'm doing it in a different manner. This sum of 3 2 to the power of 1 minus k, k starting from 1 to 20 equal to p, and also we need to find that what should it be if it was 24 2 to the power of negative k, and then k starting from 1 to 20. So or else we can do this. This very sum here can be written as sum of okay, k starting from 1 to 20, and then we can write it like 3 times 2 to the 1 minus k can be written as 2 to the 1 times 2 to the negative k. Okay, all this according to the law of exponents. According to the law of exponents, when when we have a to the power of m plus n, this is a to the m times a to the n. Okay, we can split it like that. Now we can what am I saying is that yes, because I need to have like the exponents of negative k, so this can be written as sum of This can be written as now 6 times 2 to the negative k. Okay, k starting from 1 to 20. Now equal to p. Now on the other side, we can also over here we can also write instead of writing 24, 24 is the same thing as 6 times 4, right? Or 4 times 6, okay, times 2 to the negative k. Now, this can be written as, we can take 4 as a common factor, equal to 2 to the negative k. Now, you notice that these two are the same thing. So then you can say, therefore, this part here is just 4p, okay, because this is p. So 4p. Thank you.